Let's find the solution to this system of equations by graphing. In order to use the graphing method to solve the system of equations, we need to start by rewriting each equation in a way that we can easily graph it. In other words, we need to write each equation in slope-intercept form. Or, we need to solve each equation for y. When we solve our first equation for y, we get that y equals 2x minus 2. When we solve our second equation, we get y equals negative 2x plus 6. Great! We've solved each equation for y. We're ready to graph. So in our second step, we want to graph each one of our equations on a coordinate plane. So we'll draw our coordinate plane and label our axes. And then we can graph each one of our lines. So let's start by looking at y equals 2x minus 2. Here, we have a y-intercept of negative 2, so we plot that point. Then we have a slope of 2, or 2 over 1. So we use that slope to find our next point. We start at our y-intercept, and we move up 2 and right 1. Then up 2 and right 1. Then we can draw our line. Perfect. Now let's look at our other equation. Y equals negative 2x plus 6. Here, 6 is our y-intercept, so we put a point at 6. Now we have a slope of negative 2, or negative 2 over 1. So we start at our y-intercept, and we move down 2 and right 1. Then down 2 and right 1. Then we draw our line. Now we've graphed both of our equations on a coordinate plane. We're ready to find our solution. Using the graph, we want to find the intersection of our two lines. So here, where do our two lines intersect? At this point right here, the point 2, 2. This is the intersection of our two lines. That means it's the solution of our equations. The solution to this system of equations is the ordered pair 2, 2. It's the point on the graph where the two lines intersect. But just to be sure that this is the solution, let's check our answer. So in step number 4, we'll check our answer by taking our solution 2, 2 and plugging it in for x and y in each of our original equations, then seeing if it makes a true statement. So our first equation was 2x minus y equals 2. Well, plugging in the ordered pair 2, 2, we want to see if that makes a true statement. So we have 4 minus 2, and does that equal 2? Yes, it does. 4 minus 2 is 2, and 2 equals 2. So we have a true statement in our first equation. Now let's check our second equation. Our second equation was 2x plus y equals 6. Plugging in our ordered pair, we have 2 times 2 plus 2. Does that equal 6? 2 times 2 is 4, and 4 plus 2 is 6. Another true statement. So when we plugged in our solution 2, 2 into each of our original equations, we got a true statement in both cases. That means that we have the solution to this system of equations. The solution is 2, 2. And since we have one solution, the system is considered consistent and independent.